Hello, algebra students. In this short lesson, we're going to be talking about calculating and comparing square roots. And you see there's a square root on the screen right now in front of you. What is a square root? A square root is a statement. It's asking you a question. It's asking you what number do we have to multiply by itself to get the number under the square root symbol. Now that square root symbol above 225, that whole symbol is called a radical. So the number under the radical is a number we're trying to evaluate the square root of. And we're trying to find a number when we multiply it by itself, we get 225. Sometimes square roots can be the perfect squares. The number under the radical can be a perfect square. And what that means is there's some actual whole number that we can multiply by itself as a whole number to get the number under the radical. Most numbers, though, do not have a perfect square under the radical. So like if I had a radical 2, the square root of 2, there is no rational number that I can give that when you multiply it by itself, it equals 2. And any square root that does not evaluate to a perfect whole number because it's a perfect square under the radical, any square root that doesn't evaluate to a whole number, it's going to evaluate to an irrational number, a number with a non-terminating, non-repeating decimal, a decimal that just goes on with different digits, no pattern, forever and ever and ever. So square roots can be messy, but sometimes square roots can be really clean. Like, is there a number that when we multiply it by itself, we get 225? Okay, let's say I'm exploring that question. 13 times 13 is 169. Nope. 14 times 14 is 196. Nope. 15 times 15 is 225. Bingo bango, I've got it. Now, what am I going to do to evaluate the square root? I can't tell you how many times I've seen students write this incorrectly. They'll evaluate a square root and they'll keep the radical in their answer. Like they'll say the square root of 225 is the square root of 15. That is incorrect. Once you've evaluated your square root, the radical is gone, okay? You're just going to write the number. The answer to the square root of 225, if I'm trying to evaluate it, is just the number 15. No radical. It's not the square root of 15. It's 15. And then if I wanted to get 15 back to being 225, I'd have to square it, or I'd have to multiply 15 times 15. But this is what an evaluated square root looks like. Now here's something interesting to know. You can only have, so if you're wondering if the number under a radical is a perfect square, the only numbers that could ever be perfect squares, and this doesn't guarantee that they're perfect squares, but it means they might be, they end in the digits 0, 1, 4, 5, 6, and 9. That means that if the number under your radical ends in the numbers 2, 3, 7, or 8, it can't possibly be a perfect square. You can discount it right away. You know that it's not going to evaluate perfectly. However, if it has the digits, if the number under the radical ends in the digit 0, 1, 4, 5, 6, or 9, that means it might be a perfect square. And actually, when you're thinking of all numbers that exist, it probably won't be because there's not that many perfect squares, really. I mean, there's an infinite number of them, but there's way more numbers that aren't perfect squares. So, just wanted to make sure that that's something I said. Let's get to the lesson practice so you can see how to work the types of problems that we're going to work. And hey, look at that. Letter A we've actually already answered. So letter A asks us, is the radicand in the square root of 225 a perfect square? The word radicand means the number under the radical sign. That means 225. Is 225 a perfect square? The answer is yes. 225 is 15 times 15. That's all the explanation we need for that one. Is the radicand in 350 a perfect square? Well, let's think about that for a second. 350 ends in 0, so could it possibly be a perfect square? Yes, it could be, but if it's just some number, it's most likely not. Let me just try a few numbers in a calculator here. So we know that 15 times 15 is 225. I'm going to go bigger than that. What's 16 times 16? 256. So we're getting closer. What's 17 times 17? 17 times 17 is 289, even closer. 18 times 18. 324. 19 times 19. 324, 361. So it's right between 18 squared and 19 squared. So no, it is not a perfect square because 18 squared is, and let me just make that a square sign, is less than 350, and 19 squared is more. Okay? And if it was a perfect square, it would have to be either 18 or 19. It can't be something between those two numbers because a perfect square can't lie between two whole numbers, the square of two whole numbers. So it's not a perfect square. Okay. So letter C, estimate the value of the square root of 37 in the nearest integer. So here's what you have to ask yourself. Can you identify the perfect square number that's close to 37, to the radicand here? Well, I know that 6 squared is 36. So this is really close. The square root of 37 is really close to 6 because 6 squared is almost the radicand. What about 7 squared? 7 squared is 49. Which one of those is closer? Well, obviously 36 is closer to 37 than 49 is. So I would say about 6. I could also use the equal sign that's like a squiggly equal sign to say it's almost equal to 6. And if you want to see what that squiggly equal sign is, just check out chapter 13 in your book and you'll see some examples of it. All right, compare the expressions using less than, greater than, or equal to. What I'm going to do here is I am going to compare by calculating the square roots and then doing the operation. In this case, I'm going to add things together. And let's see, 441 is one. I'm not 100% sure. I think it's 21 squared. I'm just going to work this on the side. Yes, 21 squared is 441. So that means the square root of 441 is 21. All right, so let me work the left side first. The square root of 6 is 16. The square root of 16 is 4 because 4 times 4 is 16. The square root of 441 is 21. 4 plus 21 equals 25. All right, so I've got this left-hand side done. The right-hand side is going to be, well, square root of 81 is 9. And then the square root of 361, I think that's 19 times 19. So it's going to be 9 plus, yes, 19 times 19 equals 28. That means that the numbers on the left are less than, when I evaluate it, the numbers on the right. Just please keep in mind when I evaluate these, I'm writing them without the radical symbol anymore. Okay, and then lastly, a city park has a new sandbox in the shape of a square. I'll bet we could take the square root of that square. Hey, if you know the area of a square, to find a side of that square, you take the square root of the area of the square. Okay, that's something that you can do. So, if I take the square root of 169, I'm just going to write root of 169. That's going to equal 13. That's one that I have memorized, 13 feet. That means that a side length of this sandbox is 13 feet. How do I know? The square root of the area of a square is the side length of the square. And I can double check that because if you multiply the side length times itself, in other words, 13 feet and then squared, you should get the area of the sandbox. Hold on one second. You get the area, 169 square feet. So I can kind of prove backwards that it is indeed 13 because the area was 169. And I have to square 13 to get back to 169. 13 feet is the side of the sandbox. All right. So the hardest thing you're probably going to be dealing with, there's really two things. Number one, remember not to write radicals in your evaluated square roots. Once you evaluate a square root, You don't write a radical sign over it anymore. It's just the number that you have to multiply by itself to make the radicand in the square root. It's just the number. And then the last thing is, when you're estimating, it's kind of hard sometimes to find numbers close to the square root number. What you're probably going to have to do is, if you don't have the square root memorized, just multiply numbers by themselves until you find one that's close to the number you're looking for. All right, now you're ready to do numbers 1 through 30.